All right. Hey guys, so let's look at chapter 16. We're going to start a new chapter here and trying to get it to where you can see it better. Okay, so here we are with chapter 16, Earth's Atmosphere. I'm trying to make it clear. First of all, I want to say I miss you guys a whole lot. I wish that we were in school and I wish I could see you guys and we could have fun again, but I hope you're learning a lot this way and hopefully I'll see you again soon. We're going to be on page 572 and we're looking at describing Earth's atmosphere. And our previous lesson, you were to do a vocabulary graphic organizer assignment. That probably took you a little while to do it, but you had a few days. So I figured it would be okay. Where you were supposed to, write the terms down, and I tried to put pictures that correlated with the terms, and that you were supposed to find pictures similar to that and write the definition and write a sentence using that term just to be familiar with those terms for when we were talking about it in the next 3 lessons in chapter 16. So here in describing Earth's atmosphere, we are looking at here, it says the atmosphere. It's a thin layer of gases that surround Earth. And this is a good picture describing the atmosphere. And we know that the atmosphere is here to protect us for life on Earth. If we didn't have that atmosphere, we would die. We would burn up. So it does protect us. Now we do have, we get sunburns and things like that that the atmosphere doesn't always protect us from. But we are able to live here on Earth thanks to our atmosphere. Weather occurs in the atmosphere. You can fly in the atmosphere, and we're going to talk about each layer. There are 5 layers that we're going to discuss here in this lesson. So let's look at the next page here. So origins of the atmosphere, and here's a vocabulary term: water vapor. And water vapor is the gaseous form. It's water that's in its gaseous form. So it's like if your windows get foggy, that's that liquid, and that's that water vapor that happens on your glass. All right, so it says here the ancient atmosphere. This was long ago because it says ancient. Did not have enough oxygen to support life as we know it. As Earth and its atmosphere cooled, the water vapor cooled and condensed into liquid. Rain fell and then evaporated from Earth's surface repeatedly for thousands of years. Eventually, water accumulated on Earth's surface, forming oceans. So this is how they think that oceans formed, through this process of water vapor, water in its gaseous form. Okay, so today the atmosphere has more nitrogen than carbon dioxide. Earth's first organisms could undergo photosynthesis with with the atmosphere. Recall that photosynthesis uses light energy that produces sugar and oxygen from carbon dioxide and water. The organisms removed CO2 from the atmosphere and released oxygen into it. Eventually, the levels of CO2 and oxygen supported the development of other organisms. So, composition of the atmosphere today. Today's atmosphere is mostly made up of invisible gases that we can't see. And here's a good picture, a pie chart of what these gases make up in the atmosphere. So we have 78% nitrogen, so you can see that here. I don't know how clear it is on the screen, but you can see it definitely in your book on page 575. And 21% oxygen, and about 1% water vapor, argon, carbon dioxide, and those other gases that make up the remainder of the atmosphere. Let's see. Solids and liquids that happen to get into the atmosphere. So this can be through a natural process like volcanoes erupting in this picture. So it releases a lot of soot that gets into the atmosphere, and these solid particles that can kind of pollute the atmosphere. This is a natural process of pollution. But we also know that humans can pollute the atmosphere as well through the burning of fossil fuels, driving these big trucks that put out a lot of black smoke. That's polluting the atmosphere. So that's how we talked about that in chapter 15, how we contribute, that human beings contribute most of the pollution in the atmosphere, but this is a way that large amounts of pollution do get into the atmosphere through volcanic eruptions. All right, so let's look at the next page, and I did attach this notes sheet in our lesson today in Google Classroom. So I hope you have that printed out in front of you. If not, you can pause the video and get that printed out, and that way you can keep up with the notes as we go. So we're going to talk about the layers. I said there were 5 layers of the atmosphere, and the first layer of our atmosphere, and I folded mine in half just so that way could fit it on the screen a little bit better, is the troposphere. So I'm going to write that right here. Troposphere. And the troposphere is where we live. So it says the atmospheric layer closest to Earth's surface is called the troposphere. Let me adjust this just a little bit. Okay, maybe you can see it a little bit better. So most people spend their entire lives here in the troposphere, and here's a good picture of it. It extends from Earth's surface at an altitude between 8 and 15 kilometers. The name comes from the Greek word tropos, which means change. The temperature in the troposphere decreases as you move upward. So here are some notes I want us to look at. I'm going to try to do it like this, so where you can't see all of it at once. So here's our troposphere. It's the bottom layer closest to Earth's surface. So temperature decreases as you move up. So as altitude increases, temperature decreases. Like if you're going up on a mountain, a lot of times, if you've been up on a mountain before, it's usually colder on top of the mountain than it is at the bottom of the mountain. Weather occurs here in the troposphere. Okay, so this is where weather happens. We fly in airplanes here in the troposphere. Okay, people, those are my stick people. Here we are. People live here in the troposphere. So I want you to make sure you are writing down all these notes that I'm writing down. So you'll see them all at the end, but as you go, if you have yours printed out, I need you to be filling this out as well. All right, so the next layer is called the stratosphere. I'm going to write that down here. And in the stratosphere, it says, let me do it like that. Okay, it's the atmospheric layer directly above the troposphere. So it's the one right above the troposphere, and here's the stratosphere, okay? And so here it is right here. And it extends, the stratosphere extends from about 15 kilometers to 50 kilometers above Earth's surface. So it says the upper half of the stratosphere contains the greatest amount of ozone gas. So the area of the stratosphere with high concentrations of ozone is called the ozone layer. So this is where it is. So the upper part of the stratosphere, and I put a little bracket right here, and it says ozone layer. So here, when temperature, as you increase in your altitude, your temperature increases. So it's different from the troposphere, because as altitude increases in the troposphere, temperature decreases. Well, here, as you move up, temperature increases because you're getting into the ozone layer right here. Let's see. I want you to look onto the next page. So we're talking here mesosphere and thermosphere. So the next layer is going to be the mesosphere. Okay. Okay. Let's look at this. So it says the mesosphere extends from the stratosphere to about 85 kilometers above Earth. The thermosphere can extend from the mesosphere to more than 600 kilometers above Earth. So the thermosphere extends all the way from here. It's from the mesosphere to the thermosphere, but up to 600 kilometers up from Earth's surface is where the thermosphere extends up to. And it says here, let's see, we're going to look at the meteoroid. This is where I was wanting to look at. Most meteors burn up in these layers instead of striking Earth. So in the mesosphere and the thermosphere, this is where meteoroids burn up in the atmosphere and they don't strike Earth. So let's look here at my notes. I'll open it up a little bit better. And you can see where I wrote here mesosphere, and I wrote meteors burn up, and I'm going to label this my thermosphere. Okay. All right. Now, so in this we have troposphere, stratosphere, mesosphere, and now the thermosphere. And in between these layers here is where meteoroids burn up, okay, in the thermosphere and the mesosphere. In the ionosphere, it says the ionosphere is a region within the mesosphere and the thermosphere that contains ions. So this is where those AM radio waves are, and you can see that right here in this picture, where the auroras are that you can see in the North Pole, or like in Alaska. I don't know if you know anyone that's actually gotten to see these before, but this is where this occurs, in between the mesosphere and the thermosphere. So I wrote that right here. So ionosphere, and I did my radio waves, and I wrote out here aurora. So I want you to write that down as well. All right. Then lastly, we have our exosphere. So let's write that down. All right, and that is the outer layer of our atmosphere. So it says here pressure and density are low, that individual gas molecules rarely strike one another. The molecules move at incredibly fast speeds after absorbing the sun's radiation. The atmosphere does not have a definite edge, and the molecules that are part of it can escape the pull of gravity and travel into space. So there's no definite edge here in the exosphere that marks, okay, here's the atmosphere and here's outer space. There's no edge like that. It just kind of happens that molecules sometimes escape and go out into space, if that makes sense. Okay, and so you can draw here no edge. Okay, let's look. Air pressure and altitude. So we know that, like, if you've ever been up in the Rocky Mountains, like in this picture here, oxygen is less available the higher you go up. Now, mountains, remember, they're part of the troposphere where we live. That's the bottom layer of the atmosphere, okay, the one that's closest to Earth, that strikes Earth's surface. So mountain climbers a lot of times have to carry oxygen tanks as they travel up into the Rocky Mountains because less oxygen is available. As you move up into the mountain, temperature decreases. It's cooler up here. Just remember, in the stratosphere, as altitude increases, temperature increases. And this is because, remember, the ozone layer is occurring here in the upper stratosphere. However, in the mesosphere, as temperature increases, or as altitude increases, temperature decreases again, just like it does in the troposphere. So here, altitude increases, temperature decreases. Here, as altitude increases, temperature increases. In the mesosphere, as altitude increases, temperature decreases. Now let's look here. Let's see, it says in the thermosphere and exosphere, temperature increases as altitude increases. So here again, as the altitude increases, the temperature increases, and I wrote that out to the side. So that's why it's really, really hot here in these layers of the atmosphere, and spaceships travel super fast going through the layers of the atmosphere, and that's caused in the layers those spaceships to burn up as they re-enter the atmosphere, and we've talked about that before. All right, and I believe that is all of lesson 1. So I'd like you to go back and read the lesson just so that you get a better understanding of it. Make sure you get all of these notes. I'm going to try to put them where you can see them right here. So airplanes fly here. This is where we live as humans. Satellites, they're here in the stratosphere. Okay, so you do need to know all the layers of the atmosphere and what the temperature and altitude do as you move through the layers of the atmosphere. All right, thanks guys. Have a good afternoon.